lecture series about how to handle or how to solve a heat transfer conduction problems. So this is a problem number 1 is an asbestos board is having thermal conductivity of 0.1 watt per meter Kelvin is subjected to a temperature difference of 10 degrees Celsius across its faces. The area of the board is 5 meters squared and its thickness is 0.05 meter. Calculate the heat transfer rate and the heat flux across the board. So, in this problem, the given data are thermal conductivity K is 0.1 watt per meter Kelvin and the temperature difference it's indicated as del T is 10 degrees Celsius and the area of asbestos sheet is 5 meters squared and thickness is represented by L of the asbestos sheet is 0.05 meter. So here we need to find the heat transfer rate. So the Q is equal to del T by R and resistance R is equal to, here the resistance R is equal to L by K. Here L is the length and K is in a thermal conductivity and A is area. So we substitute these all values from our given data. We know that Q is equal to 10 by R. So here we need to find these values. R is some type of value and substitute these values. It's R is in a Q is equal to represent of R and del T is a given data is 10. So the finally heat transfer rate is equal to Q is equal to 100 watt and the heat flux of the formula is the heat transfer per unit area. So this is called heat flux. So we get it the value of 20 watt per meter squared. So this is an problem 1 and final once again I will consolidate this problem is we need to find heat transfer rate. Here is the formula of heat transfer rate is equal to del T by R. Del T is a temperature coefficient and R is an resistance and the final heat flux Q is equal to Q by A is equal to 100 by 5 is equal to 20 watt per meter squared. Okay, fine. Next we have to focus on the next problem is an iron plate wall is as on an area of 4 meters squared and its thermal conductivity is 9.4 watt per meter degree Celsius at a steady state. If the surface temperature of either side of the wall is 140 degrees Celsius and 50 degrees Celsius and determine the temperature gradient in the flow direction to transfer 30 kilowatt of heat. Yes, from this given problem, the given data are the wall area is 4 meters squared and the thermal conductivity is 9.4 watt per meter degree Celsius and the surface temperature of the wall is 140 degrees Celsius and 50 degrees Celsius and we need to find the temperature gradient of the wall. So already we know that heat transfer equation or heat transfer formula of the conduction is del T by R. Del T is a temperature gradient, temperature difference and R is a resistance. Or another formula from the Fourier law of heat conduction is Ka dt by dx. Here K is an thermal conductivity and A is an area and dt by dx is equal to temperature gradient. So here the temperature gradient we need to find. So we transfer this equation from right hand to left hand side. The dt by dx of temperature gradient is equal to Q by Ka. So these all values from our given data, finally we get it the equation of temperature gradient. So the summary of the problem is, in this problem we need to find the temperature gradient. So for that temperature gradient we use this heat transfer conduction Fourier equation is equal to Ka dt by dx. So this is a dt by dx is a temperature gradient value. So we need to this temperature gradient for in this problem. So we alternate this equation is equal to dt by dx is equal to Q by Ka. Substitute these all given data values in this equation. Finally we get it this temperature gradient for this problem is 797 9 degree C per meter. Thank you.